Thank you everyone for being here today. Obviously, walking is the first step in this journey, and that starts with collecting and organizing your flood related data so that you can assess it and understand it. And this can be a big task. Making that data available to the public and stakeholders so they too can understand your data will be a key aspect of the community outreach and engagement aspects of the flood planning process. Fortunately, you probably already have some data that you can bring together that will help, even if it wasn't specifically put together for flood risk assessment. Things such as the base maps that you have, Google Maps, parcels data, stormwater infrastructure, and so forth. In these examples, we're using AppGeo's MapGeo hosted software as a service platform. It's built on Google Maps, so it's a familiar look and feel for many people. We also integrate Google Street View and other available data with your parcels data. And for example, most municipalities are not keeping track of social vulnerability index, but in this case, we have integrated that directly with the parcels data so you can see those values for every single property. And we'll talk a little bit more about that later. But basically, you provide your data, we integrate it and configure the maps for you. Within a week or two, you have a flood data management platform that can be shared securely, both internally and externally. When you share this data, you can get more eyes assisting and evaluating its completeness and correctness. Keeping in mind that sometimes you can get funding to improve your data in areas that need it. Regardless of the tool you use, you'll want to establish a flood data management and sharing platform that meets a few critical requirements. It needs to be easy to get started and easy to use and understand. It needs to help you share your information with stakeholders and the public, and it needs to help facilitate their feedback. Now, you may find that you need additional data beyond what you already have. There are many possible sources, such as the Federal Emergency Management Agency, the Center for Disease Control, and your state agencies. Here in Texas, we have the Texas Water Development Board that provides a lot of this flood-related information. In this example, we've imported the Social Vulnerability Index data from the CDC, and we've overlaid that data with the parcels so that you can easily see the SVI data for each individual parcel. We've connected to the FEMA flood zones data service, so you'll know that you're always viewing the most up-to-date information. We've also integrated the flood factor data from First Street Foundation. This is a nationally available flood risk data set that can help you get started in understanding where you may need more in-depth studies. Using cutting-edge modeling techniques, a team of over 80 scientists has calculated and made public the past, present, and future flood risk of every property in the contiguous United States. Every property is accompanied by a flood factor score ranging from 1 to 10, reflecting a property's risk of flooding over the course of a 30-year time period. You can access this data for free at floodfactor.com, which lets you enter a single address and review the data and maps for the indicated location. With a subscription, you can use the application programming interface to integrate the data into your own applications and analyses, as we've done here. Keep in mind, though, that the flood factor data is a starting point. It does not replace detailed flood studies and engineering and mitigation projects that will be needed. Again, we are visualizing this data using our MapGeo tool. But whichever flood data management platform you choose, make sure you can import many different types of data sources. Make sure you can connect to live data sources like services like the FEMA service, and that you can incorporate both public and commercial data services. To wrap up this section, once you've learned to walk, that is, once you have a handle on what data you have and what you need, then you'll begin to jog. you'll start working toward identifying studies and projects to help mitigate the flood issues in your area. Tracking project status and communicating that to your community will be important to maintain an engaged, informed, and supportive public. Regardless of your data status, community outreach and engagement are very important to the flood planning process. Making this information available to all who want and need to know will encourage their participation, representation, and buy-in for your proposed studies and projects. Let them know what's going on and how this process will help them, and they will help you make progress. MapGeo and AppGeo can facilitate all of these activities and help you get a fast start in the race toward planning and mitigation. So once you've brought all this data together, become comfortable with walking, you can begin to jog by analyzing the data to identify specific areas of need. For example, you can use something like the abutters tool in MapGeo to identify people or structures within a given distance of an identified issue. Here, you can see an example of key flood risk data, such as low water crossings and high water marks, as well as critical facilities. All of these come from public data sets, and these will be the foundation for determining impact and prioritization points. You can go on to the next slide, Aaron. There we go. We can use the Social Vulnerability Index data from the CDC to identify areas that may have more vulnerable populations, such as a high percentage of elderly residents who may have difficulties evacuating or who may be more likely to need emergency health care during a flood event. We can then overlay the flood risk data from First Street Foundation to look for potential problem areas. In this case, we may find areas where vulnerable populations are cut off from critical services in a flood event. Then we can make mitigation plans and projects to address these concerns. If we only looked at whether the critical facility would be flooded, we might miss the bigger picture of who needs to access and use that facility. So now I'm going to hand it off to Aaron, who will talk about our project in Gloucester, Massachusetts, a longtime customer of AppGeo's who has used MapGeo and other tools to really take a further step in how they address flood planning and mitigation.
Thank you, Matt. So we're taking us now to Gloucester, Mass, where they've been working to understand their flood risk over a number of years. So I'd like to share an example here from Gloucester, which is a town just about 30 miles north of Boston. And, it's a historic coastal city, population about 30,000 people. Gloucester's seen more than a few storms in their 400-year history as a town and a city. As you can see from the satellite image above, they're also surrounded by water. So with that said, coastal storms have in many cases worsened and become actually more frequent throughout the year. With much of the population residing directly by the waterfront or near the waterfront, Gloucester has really taken a proactive approach to flood management and the analysis of these data layers. So, along with AppGeo, the Massachusetts Office of Coastal Zone Management, and others, Gloucester has been working hard to better understand their risks and the measures that they may take to better prepare their community for these type of storms. You can see listed on the screen here just some of the flooding data layers that they work with. But our story today is about one of these in particular, and that's these coastal storm evacuation maps. So these areas designated A and B, colored in green and purple in this case, are the highest risk areas for flooding from a storm surge or hurricane damage. And from a planning perspective, Gloucester wanted to take this data one step further and use it as the basis for revising their existing evacuation zone maps, right? these existing zones are based on census blocks, so they're larger geographic units and they're not quite as detailed as they could be. So the issue here is that when you're relying on a larger and lower resolution geographic unit, you might overstate the evacuation need or potentially miss other critical areas due to lack of detail. So again, this previous layer was created statewide and developed by MEMA, the Massachusetts Emergency Management Agency, and they wanted to take it a little bit further due to their risk and geography as a town. So this project examined the data, taking it down from the census block level to the parcel level, where we took some of their enhanced flooding layers and examined it at a parcel by parcel level to give a much more accurate idea of which homes should be in which zone. And from a data perspective, this improvement took us from 780 census blocks and improved this resolution by about 16 times. 13,000 individual parcels now with a definite placement in one of those categories. And by linking this further to assessor data, we can generate more accurate summary tables determining what properties are at risk, what is the value of property in different categories, and then tie it to other databases like address points and schools and potential shelters. The list goes on. And this can provide planners with a far more accurate population count to better facilitate those emergency evacuation operations. Again, the staging, the emergency management in case one of these natural disasters were to occur. Now, another improvement that came out of this approach was the ability to identify addresses that were in these compromised zones. And this kind of goes back to what Matt was saying, but in a little bit more detail. You can kind of picture it as this island here where, all right, this house is safe, but everything around it is flooded, right? So you can't get in, you can't get out. What good is that when you're out of food and you don't have power? So areas of the city that might not flood but would be cut off, and this is really important when we're considering these evacuation routes, access to emergency services, access for emergency vehicles, and again, these are going to tie up very critical resources in terms of a rescue if people were trapped and they had to send a boat out there. So fatalities can occur in events like this, not just from the flooding itself, but from the isolation and detachment that can occur. This has happened time and time again, and it's especially true among those vulnerable populations that Matt had mentioned that might have a harder time getting out. So again, going purely by what's dry and what's wet isn't always the best approach, and GIS methodology such as network analysis can help us automatically detect such properties at scale and very rapidly. So here you can see a real life example of such an area in Gloucester, this peninsula here, where there's only one way in and one way out, whereas the buildings themselves don't have inundation. We're going to put special attention toward this neighborhood. I'm going to zoom in here so you can see that in more detail. Just one example of those type of neighborhoods that have been cut off. And then one step further. And this is all within that MapGeo platform. So lastly, and this is a very important one for this stage, sometimes our best data doesn't come as the output of a model or an algorithm. It comes from people on the ground who have been working in these communities for 15 or 20 years. So by involving community members and people who actually live here in the planning process, we can tap into decades of experience from those who have lived firsthand through a hurricane or a storm, and they know the at-risk areas because they've been on the ground when these things have happened. And by using an approach that combines the knowledge of city leadership, DPW, emergency, fire, police, and of residents, we can shape our models with this real world historical data to better allow them to understand what the future might bring. For an example, there could be a DPW crew who know very well that a particular bridge might flood if the culvert underneath becomes blocked with debris, which can happen when sticks from upstream get washed down, and now that road is flooding, even though the model says it's fine based on the diameter of that pipe when it's not blocked up, right? So this is local knowledge. It's an invaluable part of the process, and we want to help bring it in. So that was also part of this analysis where we kind of fine-tuned the approach based on that input. So I'm just going to show you the difference of the before and after from our Gloucester project. This is what the zones looked like originally, these larger areas. A is the higher priority and B is the secondary priority. And then after refinement, we go down to something that looks like this. So what did we learn? We learned that we can apply a lot more detail and get a much more accurate count when we take into that parcel level analysis versus census. And again, more accurate data, a better reflection of the local conditions in the history, and this leaves our emergency managers and citizens more prepared. I'm going to go with these rather quickly, but I want to touch on how cities and towns can use this knowledge in their decision making when it comes to infrastructure. Again, funds are limited. We can't just build up barriers around every house 20 feet tall. So we're going to have to choose what assets are the highest in terms of vulnerability and risk, and the highest return, cost benefit analysis can be realized. And again, saving money in the long term often can come from making these investments to just preparing for an emergency response, as you can always rebuild some roads or some houses, but you can't get a life back. And that's what makes this topic kind of more serious than a lot of the things that we work on in our day-to-day. And that takes us to our last section, which is the run. This is some of the more exciting stuff that we've come across, and what we believe is the next generation for flood prediction, prevention, and mitigation. And for this, I'm going to welcome Morgan on to talk about her work in the state of Texas.
Thanks so much, Aaron. And thanks again, everybody, for being here and sticking with us. We've just got a few more things to talk to you about, and then we'll have some time for questions and discussion. So in this next section, I'm going to be focusing on two projects out of the state of Texas that are utilizing some more advanced techniques and data sets for flood prediction, flood planning, and some geospatial analysis and visualization. Flooding, as you know, is a major issue in the state of Texas, as it is in many areas of the country. It's an issue that is dealt with at all levels of government. Federal, state, county, and local municipalities are all involved in flood-related issues. The Texas Water Development Board, or TWDB, is focused on all aspects of flooding in the state of Texas, including planning and preparation, flood mitigation and prevention, as well as response and public support during and after a flood event. AppGeo has worked with TWDB for several years on various geospatial projects. And in 2019, we worked with them on a proof of concept project to help demonstrate the value of building a centralized flooding information resource for the state of Texas. For this project, we focused on activities and questions that need to be answered before a flooding event occurs, such as understanding what areas are likely to flood based on various water levels, estimating property damages and population impacted for different flooding scenarios, and viewing real-time weather conditions and alerts for upcoming weather events. The overarching goal of this project was to build a simple platform that supported some of these key questions in a really user-friendly way. We wanted non-technical users to be able to get access to this information. Next slide. So we worked with TWDB and the Texas Natural Resources Information System Group to build the FloodSmart proof of concept application. We focused on just three core functions to demonstrate the value of this platform. First, we wanted to be able to display current weather and weather alerts from various sources, such as NOAA and the National Weather Service. Second, we wanted to provide tools for users to interactively view flood inundation modeling data. And third, we wanted to be able to estimate and display estimates for potential property damages and the number of people impacted by a flood. Next slide. To build this platform, we split the tools and functions into two separate but related interfaces. The first is shown here and is a simple mapping dashboard that gives users access to all kinds of real-time weather information, including radar data, flood gauge information, drought information, hurricane updates, wind conditions, current temperatures, etc. Any weather alerts that are specific to a user's location are displayed on the right, and a user can easily toggle between different weather layers to get a sense of current weather conditions in their area or across an entire region or state. This viewer pulls all relevant information together in one simple dashboard so that users can access all of the weather and flooding related information they might need. That theme, that concept of pulling lots of different data together in one place is something you'll hear me mention a couple times here. Next slide, Erin. So this is the second interface built within the FloodSmart application, and this is the Flood Inundation Viewer. In this short animation that's playing right now, you'll notice a user can easily interact with the map. They can zoom and pan to find the area that they are most interested in. Once they're focused on their area of interest, a user can easily change the water depth with the slide on the right, moving that up and down. As the slider is changed, the map updates immediately to display the area that would be flooded at that water level. You'll also notice that the property damage estimates and number of people impacted changes based on the inundation levels as well. So these tools are easy to use, and the information displayed is updated on the fly based on the current map extent and user-defined water level. It's a great tool for planners and public safety officials to use well in advance of a flooding event to be able to kind of see what would happen at different water levels, at different flooding levels. Typically, this flood modeling data that's displayed here is only accessible for GIS or other technical personnel sitting in a back office somewhere. And it's challenging for non-technical users to access and view this important data in a self-service way. This application solves that problem. These tools and map views get this critical flood modeling data into the hands of those who really need it and who really need to understand it. With a tool like this, public officials can view and assess potential flooding impacts and carry out planning and preparation activities and do evacuation and resource planning. This visualization can help identify areas in need of flood mitigation projects. Beyond that, we can look at comparing conditions before and after proposed projects. Matt will talk a little bit about how that might work right now.
All right, thank you, Morgan. And yes, as you mentioned, we can take this another step and start to look at how we might be able to bring in additional information and look at, for example, we're looking at a current risk assessment model and then also looking at overlaying that with transportation data layers and so forth. Now, let's say we've proposed a project. Well, we can build a new model that's based on the proposed changes. In this case, we're saying we're going to build a new detention pond here in this empty parcel, and you'll see down at the bottom, as we go through this and use very similar sort of interaction with the data, you'll see the blue area now represents where the extent of the flooding under current situations. The yellow represents what would be the situation at the same flood probability with the new project built. So again, this takes some very complicated ideas and puts it in a form that's very easy for people to understand. And again, not just scientists and engineers and planners, but the general public and politicians and decision makers can easily understand this. Beyond that, we can even start to use some newer technologies to bring in things like LiDAR data and 3D models and make those easy to view for people as well. Finally, as Erin mentioned before, sometimes that local knowledge is the most important thing that you can add. So having a tool like this where you can crowdsource information about very localized problems that maybe don't show up in the models, or receive questions about the proposed, so you can interact with the public and say, and explain why things are done the way they are, or maybe if we miss something, we can modify it and move on and improve our proposed mitigation projects. And so that kind of wraps up our demo here of our before and after comparisons. And hopefully this will give you some ideas about the types of things we might be able to accomplish once we learn how to walk and jog and then begin to run. And I'll turn it back over to Morgan now to talk about some of our current work in Harris County.
Thanks, Matt. So yeah, another, and I believe this is the last one we're covering, flood-related project we wanted to highlight today is the work we're currently doing with Harris County, Texas. You may be aware, but Harris County is the large metropolitan area that includes Houston, Texas, and surrounding areas. So that area is obviously very vulnerable to hurricane flooding. It's right on the Gulf. They have very advanced flood forecasting, flood modeling, data visualization tools, and data sets available to them. The Harris County flood forecasters need access to all of this different data coming from different data sources, and they need to be able to try to look at it all together. As a rain or flood event is approaching, the forecasters would be trying to look at all this information coming from different places, different outputs, looking at real-time rainfall data, stream gauge levels that are changing in real time, flood inundation data, looking at radar data feeds. So they're trying to, consume all of this information, and they'd be looking at it all in different spreadsheets, maps, applications, rather than being able to see it all in one place. So we are working with them to try to help solve that problem. You can jump to the next slide. So we're in the process right now of building the Harris County Flood Forecast Dashboard. So the idea with this dashboard is that it's pulling together all of the data from these various sources, including real-time and forecast rainfall and stream level data. You can see up here radar data. This is actually an image from yesterday. There was a little bit of rain in the area there. So we're pulling all this different data together, putting it into charts and graphs and tables and map views that a user can interact with. So the flood forecasters can also set up notifications within the application to get alerts. If a certain stream gauge reaches a specific threshold, it'll tell the flood forecaster, this gauge is nearly flooded or it's already flooded, so that they have a good sense of what's going on during an event in real time. Having all of this information in one place and having it being updated in real time allows the flood forecasters to provide better and more up-to-date information to the public safety officials, which is really critical during any kind of flooding event. This information in the dashboard also feeds into the public-facing flood warning system, which gets similar critical information out to the general public. We are also in the early development stages of re-architecting Harris County's flood warning system website to make it more user-friendly, more performant, more scalable. We're making to make sure that there's a mobile, a version of it that's usable on mobile devices as well.